1.6, right? This lesson, as we've been talking about limits, we talked yesterday about the idea of we have to continuity, okay? What does it mean to be continuous? And we talked at the very beginning that, in general, we talked the limit from the left equals the limit from the right, and that value has to exist at that point as well, okay? That was kind of the basic. Now, just some basic, details in this page that we'll go through before we get to some more examples. So, I kind of mentioned one-sided continuity already when we filled out that chart on the front page. But a function, it can be called left continuous or right continuous if it's continuous from that corresponding side and it equals the function value. So when we talked about, where was that chart? Right here. And we talked about, is it continuous at 9? Well, it's not your traditional continuous, but it is continuous from the left. Okay, and that's just as far as the graph goes there. So that was the idea there. So that's your left and right-handed continuous. Continuity at a point. Suppose f of x is defined on an open interval containing the point C, then f is continuous at that point, basically if the limit equals the point. When we talk about the limit, if the limit exists, that means the limit from the left and the limit from the right already are the same, and it equals that point. So that's your continuity. Continuity on open interval. Open interval it uses parentheses. The endpoints are not included. So that's just continuous A to B. Continuity on a closed interval. It's continuous on a closed interval if on the open interval and the function is continuous from the right and continuous from the left. Then we can say it's continuous on the closed interval. Okay? So that basically your function just has to go past those points for it to be on a closed interval. Continuity laws of some basic functions. This is a good one we will refer to a lot. Polynomial functions, usually expressed as p of x, are continuous over reals. Polynomials. Polynomials are just if you remember your definition from like middle school or algebra, but that's where there's just basic terms added or subtracted together where they all have the positive exponents and whatnot. So there's no x's in denominators. But polynomials, like x squared plus 3x plus 1, that's a polynomial. Well, when we talk about these polynomials are continuous functions. Whether it's like an x squared function that's a parabola, a cubic function that is some kind of increasing or decreasing function, they're always continuous over reals. And you can use that when you express things. Rational functions, p of x over q of x is continuous on its domain as long as q cannot equal 0, the denominator. Y equals x to the 1 over n, continuous if n is odd, and continuous from 0 to infinity if n is even. Okay. Sine x, cosine x. We talked about those graphs the other day, right? The up and down, those are continuous. Exponential, b to the x, that's continuous as long as this base is greater than 0 and not equal to 1. Log, so if you recall, exponential graphs are these. Log graphs are those. Okay? And so, again, continuous. Inverse functions. If f of x is continuous on an interval with range R and f inverse exists, then f inverse is continuous on the domain R. Because remember, when you take a function and its inverse, to get from a function to its inverse, you're switching the x's and y's. So you're switching the domains and ranges. Okay, so just good things to remember about some basic functions there. Properties of continuity. Given functions f and g continuous at a point C, then these following functions are also continuous. So you can take a function and multiply it by a scalar, so that's multiplying by a number, and that's still going to be continuous. You can add two functions that are already continuous. If you add continuous functions, the result is still going to be continuous. You can multiply continuous functions. You can divide continuous functions as long as the denominator one's not 0. And composition. So compositions, that's like your fog and Goff, f of g of x and whatnot. If g is continuous at a point and f is continuous at g of that point, then the composite function is continuous. Okay, so a lot of some basic stuff that if we're in it and actually doing these, they will make sense there. Okay, so let's look at some of these examples. As we look at some of these, this information right here, it says justify your findings using the 3-part definition of continuity. So that 3-part definition of continuity at the beginning, the fact that we have to prove that the limit exists. We have to prove that that point is defined and that they are equal to each other. Okay, so for c equals -3, c equals 3, and c equals 7. We've got 3 different things going here. Find f of c, the limit from the left, the limit from the right, and the limit of c. Justify your findings using the 3-part definition of continuity. Okay, how do I want to start this? Try to decide my setup here. Because we're going to write several things out for 3 different c values. So when c equals -3, it asks us to find f of c, limit left, limit right, and okay. So first of all, f of c. So I want to know what is f of -3? 2. Okay. Limit from the left. Limit as x approaches -3 from the left of f of x. What's the limit from the left? -1. What's the limit from the right? Limit as x approaches -3 from the right of f of x is also equal to -1. What's the limit then as x approaches -3? Limit as x approaches -3 of f of x is equal to -1. And we know that because the limit from the left equals the limit from the right, yes? Now, and I guess I never actually wrote that out, but is this continuous?
Yes. No.
Not continuous because we have that jump, that hole, right? So not continuous there. With that in mind, what I'm going to say here is that at x equals -3, f is not continuous, and mathematically put, the limit does not equal the point, right? So I'm going to write that as the limit as x approaches -3 of f of x. That limit does not equal the point, so it does not equal f of -3. Okay, we can do that because we've defined both of those pieces up above, yes? We defined that limit to be -1, we defined that point to be 2, and -1 does not equal 2. Let's try similar things at c equals 3. I mean, we already know, is it going to be continuous? No. Let's come up with the official reasonings, I guess. So I'm going to go same order as last time. f of 3 is equal to what? Yeah, because what's happening at 3? There appears to be an asymptote. So we are going to say D and E. The value does not exist. The limit as x approaches 3 from the left of f of x. What's that equal to? As we approach 3 from the left, it's going up to infinity, so positive infinity. The limit as x approaches 3 from the right, where's that going to? It's going to positive infinity also. So can we state the limit? Yeah, what's the limit as x approaches 3? Limit as x approaches 3 of f of x is positive infinity. With that in mind, is this continuous? No. What's my reasoning for it not being continuous? Yeah. I mean, right here, the fact that f of 3 is not defined, you could just even state that. I mean, that's our reason it's not going to be continuous, but officially, you usually tend to say that the limit is not equal to that point, because that's also a true statement. So, at x equals 3, f is not continuous. Because the limit as x approaches 3 of f of x does not equal the point, and that point is expressed as f of 3. Okay? So that's one way to say it. As I said, for continuity, that point has to be defined. That was part of our, so the fact that that point is not defined, that also is a reason that it is not continuous. Okay, what's our final point? 7. What is f of 7? F of 7 is 3. Because that's the point. What is the limit as x approaches 7 from the left? Coming from the left, it's approaching 3. What is the limit as x approaches 7 from the right?
6.
Are we good with 6? Now, what's that tell me about the limit? Okay, that limit does not exist. So limit as x approaches 7 of f of x does not exist. So I guess I should have been saying C, but at x equals 7, f is not continuous. And you can state this 2 different ways. One option, we go back to that basic of the limit does not equal the point, right? You can also state it as limit from the left does not equal the limit from the right. So, I can do what I have been doing of the limit as x approaches 7 of f of x does not equal f of 7. Or you could say the limit as x approaches 7 from the left does not equal the limit as x approaches 7 from the right of f of x. Okay, so either way, those are both valid explanations that would state that this is not continuous. Okay? Okay, so a little bit of how we, use that definition. Right there, we are kind of confirming something not be continuous. You'll notice the next part says you must be able to confirm continuity without a graph or a calculator by using your knowledge of function behavior for parent functions and their transformations. So that's like me earlier saying polynomials. Polynomials in general, they're going to be continuous. Okay, that's something we can state. Something like sine and cosine, you know what those do. They're going to be continuous. Okay. So example 4, ask us to find the values of x where the function is discontinuous. Again, this is not a calculator thing. This is using what we know. Describe the type, infinite or removable, and justify your answer by using the definition of continuity. Okay, so find the values of x where it's discontinuous. What do you know, guys? On A.
X equals 3.
Are you guys there? Because what's going to happen there? Okay, so because it's going to be discontinuous at x equals 3, we know that because that's the value that's going to make the denominator equal to 0. We know that it's going to be a vertical asymptote because it's where the denominator equals 0. Let's see. Describe the type, infinite or removable. What is this? Infinite, yes. It is a, oops, that's a horrible line, but so it is an infinite, I'm going to say, or non-removable. Okay, we already described it as a vertical asymptote, but it doesn't hurt to put it back in your notes if you've forgotten. Let's see, what was it? Justify your answer by using the definition of continuity. So, if we go into that definition of continuity, limit from the left, the limit from the right. You guys remember what these graphs look like? It's a really good one to know, especially at calc level. Do you remember what 1 over x looked like? Not a diagonal line. Y equals x is a diagonal line, but when we put it as 1 over x, we've got that vertical asymptote. This falls into, I don't know if you guys remember, we called it the reciprocal function. It was one of those 12 functions. Okay, but it is the one where there's a piece in quadrant 1, there's a piece in quadrant 3. Well, you're not, when I'm facing you, I can't tell. You just had this shape, okay? So it's those two pieces right there. That's, when you see x in the denominator, that's something we need to know. Now, x minus 3. There's a minus 3 with the x. What's that going to do? It's going to take that graph and move it where? To the right 3, because remember, when it's with the x, in the parentheses, in the absolute value, in the square root, in the denominator, it moves the graph left or right, opposite the sign. I've got my green algebra 2 paper that they're quizzing on today. Okay? But so that means that this graph that was over there now looks like that graph there. And so when we talk about this using definition and continuity, we can talk about the limit from the left and right. So this is going to be the limit as x approaches what value is our issue? Our issue is at 3. And what is the limit as x approaches 3 from the left? That's negative infinity. The limit as x approaches 3 from the right is positive infinity, isn't it? That's a problem right there. The other issue we have, f of 3, it does not exist. F of 3 is, I'm going to use the word undefined. Okay, the graph does not exist at that point. It is undefined for that point. So, and I don't have it written in my notes, but again, this right here, saying that f of 3 is undefined, that right there tells me definition of continuity does not hold. Okay, the fact that the limit doesn't equal, these limits don't equal each other, that tells me, you know, so many different ways. Okay, what about B? Yeah, always, if you can, factor that top, because what possibility exists? We could have a canceling. Okay, so always, if you can, try and cancel that top. So denominator is going to stay x plus 2. This looks like product of AC, yes? Now, can you be smart with me on our guessing game? There's no GCF, so this looks like it should go into 2 parentheses, yes? 2x squared. When we're breaking into 2 parentheses, what will 2x squared break into?
X and 2x.
Yes? Every single time. So, 2x and x. Now, if something's going to cancel, what's going to cancel? The denominator only has one thing, yes? So if it's going to cancel, there's going to be an x plus 2 to cancel. So, if I'm a smart person and guessing, I'm guessing that in this parentheses with the x is very possibly going to be a plus 2. Now, am I saying it definitely is? No, we need to check this. Now, if I put 2 here, 2 has to multiply to be what? 6. So 2 times what is 6? 3. That's my guessing game. And now what am I going to do in my head real quick? I'm going to do a quick FOIL. Does it work? 2x squared, outsides. 2x times 2, so 4x. Inside's 3x. 4x and 3x are 7x. Last, 3 times 2 is 6. I'll be honest, that's quicker for me. Can you still do product of AC, slip inside, whatever makes you happy there? Okay? So, shocker. We have a canceling factor here, don't we? Okay, so, thoughts? There's a hole? Okay. And keep in mind, this now just becomes 2x plus 3, doesn't it? Okay. So, with that in mind, let's see, you guys said it was a whole, which infinite or removable, that means it's going to be removable. I'm not against us talking whole, just official vocab. We need to remember that it is removable. Let's talk about the limit from, oh, I guess we never talked about, where is the issue? At -2, yes? You do still have to look at the fact that x equals -2 is going to be the issue. I kind of skipped over that detail. So as x approaches -2 from the left of g of x, and the limit as x approaches -2 from the right of g of x. Well, when we start cleaning this equation up, what did this equation become? This is just good math to talk about here. This became 2x plus 3, yes? What is 2x plus 3? It's a straight line that has a y-intercept of 3 and slope of 2, right? You know, so it's going to do something like this. And I'm going to have to erase part of this here in a moment. Except that what's happening? Where? So that means, okay, all of this is good. I don't know if I can erase just this part. Except at -2, which I'm guesstimating. Well, let me erase. No. Oh man. Okay, well, I'm just going to have to redraw this. You guys, probably using pencil, you guys can erase, but. I'm going to guesstimate somewhere in there there's a hole. Now, here's the deal. So that's a good equation or that's a good thing to be able to graph without the calculator. To realize, oh, hey, we're at 2x plus 3. It is the graph of 2x plus 3 with a hole. So, what's the limit as x approaches -2 from the left and the right? Now, as x approaches -2, what is the limit there? In other words, what are we approaching? We're approaching this hole. This hole is at -2, and what y value? Two times -2 plus 3, which is -1, yes? So what's the limit as x approaches -2 from the left? What's it approaching? -1. What's the limit as x approaches -2 from the right? -1. Officially, can we do this limit? We can. What's the catch, though? F of -2 is undefined. This time it's undefined as a hole. Okay? So again, you can say f of 2 is undefined. You can say that the limit does not equal the point. So, yeah. And I had written down on this one that the limit as x approaches -2 of g of x does not equal g of -2. So, again, trying to get the idea there. Okay. Ready for the next piece? Aiden's checking out. How long is homework? Is it 4? Yeah. Okay. Use the definition of continuity to find the value of k so that the function is continuous for all real numbers. Piecewise functions here. So g of x is defined with this piecewise function. We want to make sure this is continuous. Well, what do you know? Kx squared. What do you know about a graph that is something x squared? It's a parabola. It's continuous, yes? What do we know about a graph kx minus 6? It's a line. It's continuous, yes? So we know our pieces are continuous. We know we're good with a parabola, and we know we're good with a line. Where's the issue? Where what? There could be a jump if we're not careful. So what do we have to make sure that these graphs do? We have to make sure that they connect. How are we going to get these to connect? we need the limit from the left to equal the limit from the right. So what we're going to do here is we're going to find each of these limits and then essentially set them equal to each other. Okay? So, the limit as x approaches 2 from the left of g of x, we need it to equal the limit as x approaches 2 from the right of g of x. True statement? Now, what is g of x on the left? Kx squared. So what do we need to do to find this limit? We need to plug 2 in for x. So it's going to be k times 2 squared. And what is k times 2 squared? 4k. So what I'm saying there is the limit on the left is equal to 4k. I'm not sure I like how I set this up. I think I like how I set it up in notes better. That's all right. Okay, on the right, limit as x approaches 2 from the right. Now we're using kx minus 6. So kx minus 6 means I'm doing k times 2 minus 6, which is 2k minus 6. Can you find k? Subtract 2k over. So then you have 2k equals negative 6. Divide by 2, and k is negative 3. Okay. Now, with that in mind, we need the limit from the left and the limit from the right to equal. Does that happen now? If we put negative 3 into 4k, 4 times negative 3 is negative 12. If we put negative 3 in here on the right, 2k minus 6. 2 times negative 3 minus 6 is negative 12. And so we were able to accomplish that limit now, we can state that the limit as x approaches 2 of g of x, both sides we have equaling negative 12, so that's good. I was looking to see. So I'm going to say g of x is continuous. We can all spell quite well right now, right? At x equals 2, if k equals negative 3, and then we know at that point that g of 2 is equal to the limit as x approaches 2 of g of x. Okay? And again, I know it gets annoying rewriting this every time, but I'm trying to get you used to some notation here. Okay? Multiple choice, it doesn't matter. Okay? This notation doesn't matter. Free response problems, guess what? Notation matters. There's lots of right ways to do it, but there's also wrong ways to do it. So, oh, I guess I was going to state these equal negative 12 over here. Okay, so B. What do we need to figure out?
If they equal each other on both sides.
Yeah. We need to figure out that limit from the left and the limit from the right. What's the important value here? 4. So let me start with the limit as x approaches 4 from the left of h of x. What are we going to get there when we do the limit from the left? Oh. Well, okay. I started writing that. I should have backed up. Yes, we're going to get 4 minus 4 over 4 minus 4, so 0 over 0. But, okay, we're approaching from which way? The left. So reason this. If we approach from the left, could I use 3.9? We did something like this on that last quiz. We're approaching from the left. Could you use 3.9999999? Yeah, we're approaching from the left here. We want to know the limit as we approach from the left. Now, in this one, it's going to work out well. What is 3.9 minus 4?
I'm really bad at that.
Officially, it's 3 9/10 minus 4. That's 1/10, right? But it's the negative, yes? 3.9 minus 4 on the bottom is negative 1/10. What happens here? You get a positive 1/10 divided by negative 1/10. Ultimately, the key is that this becomes negative 1. Okay? What about the limit as x approaches 4 from the right of h of x? Now, on the right, can we just plug in 4? Yeah, we don't have the fraction issue or whatever, so if we plug in 4, 5k minus 4 times 4 is going to be what? 5k minus 16? Okay, what's the idea? We have the limit from the left and the limit from the right. What do we need them to do? We need them to equal. So I'm going to set 5k minus 16 equal to negative 1. Can you do some math there? Do we agree on our k value? Okay. Check it out. Does this agree? Okay. We know that limit on the left is going to be negative 1 no matter what you do. On the right, 5 times 3 minus the 16, 15 minus 16 is going to be negative 1. So we made it happen. So what do I want to say? H of x is continuous at x equals 4 if k equals 3. And we know the limit as x approaches 4, goodness, of h of x. And I guess one thing we didn't talk about, but it's going to equal h of 4. We said that all equals at negative 1. Okay? Okay. Okay. Example 5. Given h of x, piecewise, this is a good one to look at. For what values of x is h of x not continuous. So notice it says for what values of x. What about individual pieces? Negative 2x minus 5. Is that continuous?
Yes.
Okay, what about 3?
No.
Yeah.
3 is a, what's the graph y equals 3?
Oh,
Horizontal line, right? Negative 2x minus 5 is just a diagonal line. What about x cubed minus 6x plus 3?
that's a B. Absolute value. No, that's not right.
Is that the
That was
the list, the
stupid.
one thing?
It's just a cubic, yeah. Just some kind of like that. Who knows? Maybe it does something like that. You know, it all depends on what that 6x causes it to do. But it's continuous, okay? It falls into that polynomial category, okay? Now, where is this not going to be continuous? If there's a point where it's not continuous, where's going to be the key catch? The where? The negative 2, yes? If- Because that's where they all connect here.
Oh.
Okay, so what do we have to know? We need to know what each of these pieces are doing, yes? So if we look here on the left, negative 2x minus 5, what is that when we plug in negative 2? That's going to be what? 4 minus 5, negative 1. Well, right there, do I have a problem?
Yeah.
Yeah, because at negative 2, what's my graph equal? 3. I've got a problem already. What about my right? Negative 2 cubed minus 6 times negative 2 plus 3. That's what my brain says. Negative 8 plus 12. Negative 8 plus 12 is 4. Plus 3 is 7. Mental math, right?
Yeah, I got 23. But I figured it out. I forgot that the 8 was negative because
I would say somewhere you left out, you got a sign wrong. That's all I know. Okay, so right here, we know it's definitely not continuous, right? Okay, the key, it says to justify. So the first thing we talked about is that, and I'm just going to write this down, each piece is continuous. And why did we talk about each piece is continuous? Because we could go back to that generalization of polynomials are continuous. Okay, so that right there is good. But then we started running into problems, yes? If we go through each of these things. What is the value of the point? H of negative 2 is equal to, at negative 2, it's equal to 3. What about the limit as x approaches, what is this, negative 2 of h of x? What's just the general limit going to be if we don't do left or right? Because definition of continuity doesn't specify left or right. That's kind of your pre-work. What's the limit of as x approaches negative 2 going to be? D&E, because they don't equal each other, right? The left and the right don't equal each other. So this is does not exist. Well, so if you go back to that front page of these notes, f of c is defined. We gave h of negative 2 equals 3. The limit must exist. Well, right there is a problem. The limit does not exist. And then the other part is that the limit as x approaches negative 2 of h of x is supposed to equal h of negative 2. But what happened? They didn't equal, right? So the two pieces, you know, these right here are the two justifications that this is not continuous. Okay? Trying to think what else I have. I just have wrote conclusion. Conclusion. H of x is not continuous at x equals -2. And I guess what I should have set up here is this is the limit, what, as x approaches -2 from the left, and this was the limit as x approaches -2 from the right. I never wrote those out officially, and I probably should have, but I'm also trying to keep an eye on time and keep us moving. Okay, so the idea, you've got a line, a cubic, they're not going to meet, and then you've got, you know, on top of that, a point. Okay, last page. I don't know if I can quite make it, but we're getting close. Okay, use the three-part definition of continuity to create a system of equations. Then find the values of a and b so that f of x is continuous for all real numbers. Okay, well, let's start by looking at limits from left and right. The limit as x approaches what value? -1. I'll start with from the left of f of x. What piece am I using there? It's the 2ax minus b, right? And actually, you know what? I'm going to replace a of x, or f of x with 2ax minus b. When we plug that -1 in, what are we getting? Yeah. 2a times -1 minus b. So it is -2a minus b, correct? Limit from the right. Limit as x approaches -1 from the right. Which piece am I using here? ax squared plus b. Are you with them? Plugging in -1 for x, so a times -1 squared plus b, that works out to be what? -1 squared is +1, and we have a plus b. Now, that's the left limit and the right limit. We're trying to make this continuous. So, yes, the left limit and the right limit have to equal each other, but that's not where I want to go with this. What else, though, do they have to equal? They have to equal 6 because f of -1 is defined to be 6, right? So I'm going to set up an equation that -2a minus b has to equal 6 and a plus b has to equal 6. Fair enough? Now, it said, create a system of equations. This is Algebra 1, folks. I created a system of equations. Then find the values of a and b. My suggestion would be elimination. My b's already have opposite signs, so what could I do? -2a plus a, -b plus b, cancel. 6 plus 6? 12. Remember elimination? I just added like terms. If negative a equals 12, then a is negative 12. If a is negative 12, could I plug this into one of the others? I mean, if I use, what, a plus b equals 6. So negative 12 plus b equals 6. So that means b is 18 when I add it over. So a is negative 12. B is 18. What else did we have to do? I guess the other parts I just have, and I'm going to go to the other page. I just have written that, like f of negative 1 is 6, the limit from the left equals 6, the limit from the right equals 6, so thus the limit equals the point. Okay, I'm going to jump down to the bottom because I know we are about out of time. Down at the bottom, you know that the function value and limit value can exist independently of each other. Let's summarize the big ideas of continuity on intervals at points and one-sided limits. So these are quick, easy answers, or quick answers at least. I think they're easy. On A, we're using g of x right here. The limit as x approaches 3 from the left of g of x. 7, because you're going to do 2 times 3 plus 1, and you get 7. What about the limit as x approaches 3 from the right? 9, because we're going to use 3 squared. What about g of 3?
2.
No? No?
D.
When does g, defined here, when does g equal 3? On the right side. So that means we have to use the right side definition because it says when x is greater than, so that's right, or equal to, and I don't think that's something that had really come up, so I'm glad that came up. If you have, we don't ever say just x equals 3. There's x less than, x greater than. The equal to falls in there somewhere. Use whichever piece it is. Fair enough?
So that'd be the filled answer.
Yes. Yes. Okay. Limit as x approaches 3 of g of x. Left didn't equal right. Is g continuous at x equals 3? No, why not?
Because the limit of x to 3 doesn't equal g of 3.
Limit from the left? I was going to say the limit from the left does not equal the limit from the right. I should have a g of x in there, and I skipped it. However, I also agree that the limit does not equal the point. So, or you could say the limit as x approaches 3 of g of x does not equal g of 3.
Wow.
Okay. Summary, if the function is continuous at a point, the function value and the limit value are the same.
Yeah.
Okay, I am 99% sure I made the homework answer key available yesterday. If nothing else, I guess it's maybe something you screenshot so you can have it available without Wi-Fi, right?